What is fundamental? What is fundamental physical quantities? Quantities like which does not depend upon other quantities, right? Quantities which don't depend upon other quantity is called fundamental physical quantity. Fine. Quantities which don't depend on other physical quantity, on another physical quantity, right? Another physical quantities are called another quantity. Got it? Are called what? Fundamental physical quantities. Fine. Example: there are seven kinds of physical quantities. How many kinds? There are 7 kinds of physical quantities. Okay. It's having how many kinds? 7 types. There are 7 types of what? Fundamental physical quantities. It's having 7 kinds. Okay. Fine. Example: 7 kinds of what are there? Just copy it. Then I will just rub it off. Just copy. I will just rub it off. So, seven types of what? Of fundamental physical quantities. Okay. A, what? Tell me. Then B, mass. C, time. Okay. Okay. And D is what? Temperature. C, D. E. Fifth one, length, mass, time. Then electric current. Then luminous intensity. And last one is mole. Fine. Luminous intensity. Last one is mole. Or I can say amount of substance. Okay. Actually, the better body, amount of substance. These are all the kinds of fundamental physical quantities: length, mass, time. Okay. Now here unit. Length will be what? Meter. Here mass unit is what? Actually, I am talking about SI unit, kg. And time, second. Temperature, Kelvin. Electric current, I will write unit here, ampere. Luminous intensity, candela. Luminous intensity unit is what? Candela. And amount of substance, mole. Okay. Can you see the board clear? I will write on top little bit. Wait, I will write this. Last one I will write it here. I think it's not visible. Last one, seventh one I am going to write here. Seventh one. This is seventh one.
Type there, ma'am. Join via device order.
Amount of substance. Right? This is seventh one I have written here. Okay, unit is what? Mole. These are the seven kinds of what? Fundamental physical quantity. Once again. Okay. First is what? Length. Unit is what? Meter. Second one is mass. Unit is what? Kg. See, third one, time. Unit is what? Second. Fourth one, temperature. Unit is we are measuring in terms of Kelvin. Okay, then fifth one, electric current. Unit is ampere. And sixth one, luminous intensity. Unit is what? Candela. Unit is candela. Fine. And seventh one is what? I have written here, amount of substance. Okay, unit is what? Mole. Here we are talking about SI unit. Fine. Fine. Now, this is all about fundamental physical quantity. Second type is derived physical quantity. Derived physical quantity. Like quantities which are derived from fundamental physical quantity are called derived physical quantity. I am dictating, you can write it down. Quantities which are derived from fundamental physical quantities are called derived physical quantities. Example, or you can write like this. Quantities which are derived from fundamental physical quantity. Fundamental physical quantity. Physical quantities are called derived physical quantities, right? F is sixth one. F is sixth one. That's the number. Like first, second, third, fourth, fifth, sixth. F is what? Sixth number. That's all. I wrote like A, B, C, D, E, F like that. Fine. Are called derived physical quantities. Fine. Example, like area. Example is what? Example, like area. Why? Because area means what? I can say length into length, right? Length into, or you can breadth, you can say, right? This is the area. Okay, breadth is kind of length only, right? I am talking about here only like unit. Okay, so breadth unit again it will be length only. So I can say area is what? Length into length. So I am deriving this from fundamental physical quantity. Fine. So length unit is what? Meter. And this is also meter. So meter square. That's all. Got it? So these are area, then force. They all are derived because force I will derive. Force is equal to what? Mass into acceleration. Fine. So mass is coming here. So I am deriving it from fundamental physical quantity. So these all are called derived physical quantities. Fine. Mainly, see in India, from where question will come, I will tell you. They may ask you to write a dimensional formula. Fine. So I will write few dimensional formula and I will teach you how to write dimensional formula. Have any doubt, you can message in chat. Students, if you have any doubt, you can message in chat. Okay? So that I could see here. Fine? Any message you can do, I'll just let it know. Fine. So now see. Have you question? Right, we don't have digital board. Right. We don't have digital board. Right? Dimensional formula. Okay, so see here, if I write here force, what? Force. If I have to write dimensional formula of force, that means we have to write the dimensional formula in terms of what? All the physical quantities. Seven fundamental physical quantity. Fine. So see here, force, I can write what? Mass into acceleration. Fine. Mass means what? So, okay, fine. So before this, you should know, actually in dimensional formula, mass we notate it by m. Mass is notated by m. Similarly, length is notated by L. And time, we write capital T. This is how we have to go through. Fine. Mass we notated by m. Length by capital L and T and time by T. Fine. So see here how I am doing here. What is acceleration? Mass means what? Kg, right? Okay. So mass notation is what? M. And see, acceleration means what? Acceleration means meter per. Okay. Fine. Acceleration means what? Meter per second square, right? Acceleration means what? Meter per second square. Acceleration means what? Meter per second square. So see, meter means what? Again, length, right? So mass means m. Meter means what again? Length. Per second square means what? I can write like this. Kg into meter by what? Time square, right? Second means what? Time square, right? Kg into meter by time square. So kg means what? Mass. I will notate it by m. Okay, and see here, meter means what? Length, and divided by t square. So this will become ml t to the power minus 2. That's how we have to write dimensional formula for any physical quantity. Okay, got it?
Yes, sir.
Next, so many examples are there. So many. We have so many examples. Let's see. Okay, get me this value. Next, note it down. Note it down. You got the procedure how to write the dimensional formula. Mass noted by capital M, length by capital L, and time by T. Fine. Okay. Similarly, see here. Suppose that the dimensional formula of force is what? mn p to the power minus 2. And
You stand there, then they can see it.
so this is the how to write dimensional formula of force, right? Force, as we know, mass into acceleration, right? Mass notation in dimensional form is what? Capital M. Acceleration means what? Meter per second square. Meter means what again? Length only, right? Meter means length. So I wrote for this L, and per second means I wrote in denominator T square, because this is second square, so T square. T goes on top, and it became minus 2. Fine. So this is how we write dimensional formula of force. I will give n number of examples. Don't worry.
Get out of this. Good.
You're right. Then
Yes. Torque. Torque. What is torque? So this is force into distance, right? Distance I can write in terms of meter, right? Torque is what? Cross product of what? Torque about any axis is what? Cross product of what? Distance from the axis and force, right? So force into meter. Meter dimensional formula is capital L, and force just now we wrote dimensional formula ml p to the power minus 2. So L to the power 1 and 1, it became 2 here. So this is the dimensional formula of force. Sorry, torque. Wait, thanks. Fine. Next. Celerabito. Any force. Force means any kind of force, right? Force. Just I am writing here what? Dimensional formula. Force means once I get into torque and all, due to slow of motion, then I will tell you what is force. Here, just I am teaching you how to write dimensional formula in a physical quantity. That's all. Okay. Got it? So as you know, force is what? This is Newton, right? What is the definition of force? That I will get into again. Once I start teaching you Newton's law of motion, right? Fine. Yeah, it's a force into meter, correct? It's a force into meter, yes. Yeah, it's a product of force and meter. Meter means distance, I can say. Yes. For if you doubt, you write here distance. You write here what? Distance. That's all. Okay. So torque is equal to force into distance. Fine. Similar other thing I can write.
Yes, sir.
Suppose that I have write dimensional formula permittivity of medium. Permittivity of medium. You know epsilon, right? You know electric force. What is force value? Force between two charged particles. F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square, right? So here I am going to write, okay, dimensional formula permittivity of medium. This is what? Epsilon. Fine. Fine. As you know, force is equal to 1 by 4 pi epsilon naught. Okay, epsilon 1 will be right into Q1 Q2 by R square. So force means what? Just now we got Mn Q2 minus 2 1 by 4 pi, or I can write like this. This is Newton. This is 1 by, or I can say 1 by 4 pi epsilon into charge. This is not permittivity. Permittivity. You are in 12th or 11th. You know, if two charged particles are kept at distance r, they will apply force on each other, and value of force is equal to 1 by 4 pi epsilon into Q1 Q2 by r square. Epsilon is called permittivity of the medium. Fine. Got it? So Newton into 1 by 4 pi epsilon into charge square divided by what? R square. R means what? And right, R means distance only, right? This is distance square. Fine. So I have to find this epsilon. I will take this along this side. So epsilon into what? Charge square divided by Newton into. Oh, it's not seen here, right? I think they can't see. They can't see. I have to go ahead. What? What kind of nonsense you are saying? See, as just now I got it coming. Okay, to explain what Coulomb's law. All these things I will explain when I am dealing with electrostatics. Right? Don't worry, one by one. Please bear one thing in mind. As of now, I am teaching you how to write dimensional formula. That's all. Got it? I think people are feeling difficulty in doing this. Fine. Fine. Wait. If you have now difficulty, see, let us start with a small thing only. Then I will get into this. See. Wait. Let's go. Permittivity of the medium, like it's like it's epsilon, right? Like it depends. Like see, when Coulomb's law was derived, right? So what happens? They were doing experiment with with taking two charged particles, right? So what happens? While calculating the force, F is equal to, they replaced, they say what this is proportional to K into Q1 Q2 by R square. Fine. And after experiment, they got to know that K is equal to 1 by 4 pi epsilon, right? Epsilon is called permittivity of the medium. That's all. Right? It will affect your Coulombian force. Okay, there are two kinds of things. Permittivity in case of Coulomb's law, and in magnetism we are getting permeability. Fine. Got it? Once again I am telling you, I am teaching you now to how to write dimensional formula. Okay? Fine. Once I get into electrostatics, I will tell you what are like quantities are. Got it? Go ahead. For free space, this will be epsilon, and this value will be 8.85 into 10 to the power minus 12. This is called epsilon. Okay, this is called permittivity of free space. Permittivity of what? Free space, epsilon. Fine. Permittivity of Fourier space, epsilon. Fine, value will be 825 into 10 to the power minus 12. Please don't deviate me from this unit dimension topic. Ask questions related to unit dimension only. Once again, I'm telling you, once I get into electrostatics, then I will explain all these things. Here I'm teaching you how to write dimensional formula. That's all. Please stick to this only in today's class. Otherwise, you know what will happen? I will get distracted. I will start teaching you something else. So I am catering need of all the students, not a single student. Fine. All right. Okay. Fine. So similarly, if I have like dimensional formula of momentum, right? Momentum means what? Linear momentum. Here, linear momentum, right? It's equal to what? Force into time. Linear momentum means force into time. Force again, Newton into time means what? Capital T. And just now I wrote the dimensional formula of force. What was it? ml p to the power minus 2 into time. So this will become ml p to the power minus 1. That's all. Okay. Fine. Linear momentum. This is what? Linear momentum. Force into time. Force means what? Newton into second. Okay. And just now I wrote the dimensional formula of Newton, right? ml p to the power minus 2. Fine. Just multiply, you get this value. Okay. So likewise, we can write the dimensional formula all the physical quantities. Yes. Yeah, linear momentum can be taken in terms of mass and velocity also. Yes, yes. From there also we can derive. But here I derive because already I have derived what? Force, right? That's why I wrote directly. Yeah. Similarly, what? Impulse. Impulse, right? Impulse. Impulse means what? What is impulse? F into delta T. When any strong force is acting for short duration is called impulse, right? Or this. So what is this actually? Same thing. Its unit is what? Again linear momentum only. Fine. So dimensional formula of impulse will be same as linear momentum. Fine. ml e to the power minus 2 into what? T. So this will again equal to ml e to the power minus 1. Fine. Got it? Similarly, see, next one is, suppose that I have to write dimensional formula of surface tension. What? Surface tension. What is surface tension? Force per unit length, right? It acts on the surface of the liquid, right? This force acts on the surface of the liquid. Fine. This is the property of the liquid by virtue of which it will apply force on neighboring molecule, right? So this is what? Force by what? Length, right? Again, so this will become fine. Done with this. I will complete the dimensional formula of permittivity of the medium also, right? So I thought, okay, before getting to that, so many students are not understanding, like, the basics. So I am starting with basic first, then at last I will write the dimensional formula of this also, right? Don't worry. Next. So surface tension. Here I am writing what? Surface tension. It will be what? Surface tension means what? Force divided by length, right? Force ml t to the power minus 2 divided by L. So this will become m t to the power minus 2. That's all. Okay? Note it down. Fine? Okay. Can you have, I'm giving you, okay, assignment. Just do it now. Pressure. Right? Dimensional formula for pressure. Pressure. How to write pressure dimensional formula of pressure? Can you see? Pressure, say, write bigger one. It is bigger. Pressure. Pressure. Okay, write dimensional formula of pressure. Pressure is nothing but what? Force by area, right? Force. Yes, very good. Very good, Nihal. Very good. Very good, Nihal. Yeah, force by area, correct. So force by area. I will at last I will write. Don't worry. Permittivity I will write at last. Pressure is equal to force by area. Fine. Let me just take cross check here. So force means what? ml t to the power minus 2 divided by l square, right? So this will become ml minus 1, 1 minus 2 and t to the power minus 2. Fine. Got it? Not minus 2 l to the power, say minus 1. Okay? Pressure. SI unit of pressure is what? Tell me, Pascal, right? Pascal. Okay? Pascal. Got it? Not mute. It's fine. Similarly, energy. No need to copy fast. Please copy fast. Energy. Energy. What? Oh. Energy, right? Energy. Energy. What is SI unit of energy? Joule. Energy SI unit is what? Joule, right? Can you have dimensional formula of energy? Can you have? I'm giving you 1 minute time. Energy. Energy again what? Force into energy kind of dimension wise work done only, right? So work done is equal to force into again what? Force into displacement. Force into what? Displacement. Fine. So what is force? Just now we did ml t to the power minus 2 into what? L. Fine. So this will become ml square t to the power minus 2. That's all. Energy, work done, all will have same dimensional formula. Got it? Similarly, power. Power means what? Tell me formula power. Energy by time, right? Energy per second. It's called power. Power, right? Power. SI unit power is what? Watt. Watt. W-A-T-T. Watt. So this can be written energy by time. Energy divided by time. So what is energy here? Just now I wrote energy. ml square t to the power minus 2 divided by t. Fine. So this will become. I will write on top. I will write on top. I think it's not. Is it visual to all of you till here? Can we comment? Is it visual till here? Okay, thank you. Yes, fine. Till here, copy. I will just write it here. One question, okay, maybe coming from the national formula in the exam. That's why I'm okay. Right, make you write so many things. Fine. So I will just continue it here. So this will become power means what? Just I'm writing here again. Power, right? So dimension formula will be. See, this will go on top. So this will become ml square t to the power minus 3. That's all. Next. Next, intensity. Next is what? Intensity. Intensity. Fine. Intensity. How do you define intensity? Intensity is energy falling per unit area per unit time. Energy falling on any surface per unit area per unit time. It's called intensity. Fine. Got it? So this is energy falling per unit area per unit time on any surface. On any surface. It's called intensity. Energy falling per unit area per unit time on any surface is called intensity. Fine. Like intensity of intensity of sound, then intensity of light. Fine. Okay. So this is energy falling per unit area per unit time is called what? On any surface. It's called what? intensity of light. Intensity. So this will become. So see, energy. Just look here how to write it. Energy per unit time. Nothing but what? Hour or not? See, it's energy here and just look here. Per unit time means what? Power, right? Per unit area means what? Divide by area. So I can write watt by area. Fine. Watt by area is called what? Energy, right? Now, watt means power, right? Or you can say power by area. Better you say power by area. Fine. Power divided by area will give you intensity. What is power here? Power just now I derived power, right? Tell me power. ml square q power minus 3. Please just check it. Is correct? Cross check it. Just now I have made you right. Yes, fine. ml square q power minus 3 divided by area means what? Meter square, L square. So this will become m L square cancelled out. So we will have m into q to the power minus 3. Got it? Yes. Are you getting it, students? Any doubt? Okay. Thank you. Go ahead. We'll go ahead. Don't worry. We'll take each chapter like this only with concept. Okay. Don't worry. My target is to score out in physics, and easily it can be done. Scoring out in physics in India is not a big deal. Only just stick to your NCERT concepts. That's all. Fine. Scoring out in physics is very easy. Last year, I think last year physics. Okay, I think first time they have asked question from calorimetry. So far it was not asked. First time it was asked question from calorimetry in physics. That's what I'm saying you. Don't leave even single topic. Okay, just have an idea of all topics. Got it? What's the time? Next is write answer formula of moment of inertia. Moment of inertia. Moment of inertia, right? Fine. Moment of inertia. So this is nothing but what? Moment of inertia of a particle about any axis is what? M into r square, right? Where r is distance of particle from the axis, right? Like this it is, right? See here. If any particle rotating, mass m and r is distance. If particle rotating about this axis, right? So what is moment of inertia of this particle? It's mr square. Fine. M r square, right? So this will be m into l square. Fine. Next, derived of angular momentum. What? Angular momentum. Angular momentum. What is angular momentum? I think it's a product of moment of inertia and angular velocity, right? I omega. I into omega. Omega is called what? Angular velocity. So how much it will be? Tell me. Write the formula of this. Dimensional omega means what? Omega means what? Radian per second square, right? Okay. All right. So okay, fine. Yes, mock test will be there. I got one question in comment. They didn't get what is moment of inertia, right? Moment of inertia is calculated about an axis. Fine. Of anybody. If anybody rotating, right? How much resistance it's like see inertia. What is inertia? It's property of the mass. Higher the mass, okay, more it will resist in change. Similar way, more is moment of inertia, more it will resist in rotation. Okay, you will have to apply more torque to rotate the body if it's having more moment of inertia. Fine, got it? So moment of inertia about any axis. Suppose this is the or we do like this. See the axis about which any particle of mass m is rotating, and perpendicular distance from the axis is r. Okay, this is the axis about which this mass is rotating. Fine. Okay, so moment of inertia of this particle of mass m is equal to mr square. This is called moment of inertia. Got it? This is mr square. Moment of inertia is equal to mr square. Fine. Understood? Hope we got clear idea about moment of inertia. Fine. It's just a resistance of rotation, like your normal inertia. Normal inertia is what? Resistance of change. It's a property of mass. Higher the mass, higher force you will have to apply to move the body. Similarly, higher the moment of inertia, high torque you will have to apply to rotate the body. That's all. Fine. And how will you define? M into R square is moment of inertia of any body. I'm talking about discrete body here. About an axis. Fine. Fine. So now let's start with angular momentum of any body. Angular momentum formula is what? I into omega, right? I means what? See, I means what? mr square. Omega is what? Radian per second. Radian per second. Fine. Velocity means what? Radian per second. So this will become m. M means what? Capital M, kg. R means what? Distance, length square. So L square. This is for moment of inertia into radian is dimensionless. Second. Second means what? T to the power minus 1 per second. This is right. If you multiply all, you will be getting ml square T to the power minus 1. Fine, got it? Students, send it out. Yeah, correct. Yeah, angular momentum formula is correct. Correct, Rahul. Yes. Yes.
Sir, could you please explain one more time?
Yes. Write in the question in comment, please. Write question in comment. Radian, okay, yeah. Radian per second. Radian is like this is unit of angle. Pi radian is equal to 180 degree, right? Suppose that any body is rotating, any particular rotating is okay. Suppose that it was at P, fine, and in delta theta it went to position Q, and this angular displacement is delta theta, right? Fine. So delta theta represents the radian. This is a yeah, that's what I'm saying. Dimension, radian is dimension, yes, correct. But per second it is there, right? That's why T to the power minus 1 I wrote. I wrote this per second, not per radian. Yeah, radian is dimensionless. Got it? Radian is dimensionless, correct? Got it? Yes. Yes, Rahul. Yes. Yeah, that's what I wrote p to the power minus 1 for omega. For this, I have written p to the power minus 1. Correct? Got it? So this will become ml square e to the power minus 1. Fine. We'll take a short break here. Then again we'll resume shortly. మమ్మీ ఉంది Okay, fine. So, okay. Now, dimensional formula of coefficient of viscosity. Coefficient of what? Viscosity. Notation is eta. Coefficient of viscosity. How will you define viscosity? Coefficient of viscosity. Fine. This is like, it's like kind of friction coefficient, right? This is the property of the any fluid material, right? I mean fluid particle, because of which they will apply resistance force on what? Between the layer of the surfaces. This is the what? This is the property of the what? Liquid, right? Higher the coefficient of viscosity of the liquid, it will apply more force, okay, on the surface in contact. Fine. So we can derive it like this here. Coefficient of viscosity, Cn of viscosity is equal to shear stress. Shear stress divided by what? Area. Area. Fine. Which area? Area in contact. Shear stress is what? A stress. What is the formula of stress? Force per unit area. So this will become, force, viscosity, shear stress. Sorry. I made mistake. Sorry. My velocity gradient. This is coefficient of viscosity is equal to shear stress by velocity gradient. Fine. Okay, fluid mechanics I will we'll talk deeply about this. Fine. Just for the time being, you understand that formula of coefficient of viscosity is nothing but shear stress divided by velocity gradient. Fine. Okay. So what is shear stress? Obviously, force divided by area. This is shear stress. For a stress means what? Force per unit area. Shear means what? It will act parallel to the surface. That's all. So a stress is force by area. Velocity gradient means what? Gradient means what? Rate change of velocity with length. Change of velocity with length. So I can write here velocity by length. I am writing a small l. Okay, don't get confused with capital L, right? Fine. Once I write the formula, then I will convert everything into dimensional formula. So this will become force into length. A is what? L square into what? Velocity. Velocity means what? This is velocity. Wait, I will write on top. So this will become. Wait, I will write on top. Copy to here, please. So let's place it out. Shear stress. So I wrote here force by area. Velocity gradient means what? Velocity divided by what? Length. Right? Gradient means what? dv by dl. Fine. This is velocity gradient. Fine. So this will become, this copy to here, please. Then I will. Okay. Fine. Hope we have done with copying. Here, comment now. Comment. Fine. So this will become. Okay. Fine. So this will become force by area. What is force by area? Force dimensional formula is what? Just now we did Newton, right? Dimensional formula of Newton is ml t to the power minus 2. Okay, area. Area means what? L square into velocity means what? Meter per second. So velocity will become L t to the power minus 1. This length will go on top. So I am writing 1 in here. This is for this length, velocity by length. So see what you are getting here. L cancel, L square L to the power minus 1. So you are getting M L to the power minus 1. Sorry, minus 1. And see T to the power here minus 2. Minus 2. This minus 1 will go on top. It will become minus 2 plus 1. So minus 1. So this will become T to the power minus 1. That's all. Hope we got it. please. Yeah. Here now. Yes. Good. Any doubt? Understood. Any doubt? If you have, please write in comment. Okay, fine. Next. Now let's come to permittivity. Okay, that I have left that time. Permittivity. Okay, after we see how I'm writing. See how I'm writing. Please understand. Permittivity of the medium, right? Same thing. Fine. So see, I will write the Coulomb's law of force formula. This is F is equal to 1 by 4 by epsilon. Epsilon I'm writing because I'm not taking here medium as by Q. Okay, this is generalized for all kind of medium into Q1 Q2 by R square. Fine. Now see, I need to get this. I will take this epsilon on this side. So what you will get? Epsilon is equal to 1 by 4 pi F into Q1 Q2. Q1 means what? Q1 into Q2 by R square. Divided, okay, fine. 1 by 4 pi. This is dimensionless. So no need to worry about this. Got it? Now see, 1 by F means what? F means what? Newton. Now, what is Q? Q is equal to what? Current into time. Fine. So for current, I can notate it by capital A or capital I. Fine. So I will write here A into T. T means what? Capital T, right? Are you getting it? How I'm writing? This is for this Q1. Q is equal to current into time into this one Q2. Again A into what? Time. Fine. Now force means what? Newton I got, right? Newton means what? Just now I wrote the formula. This is appearing. L e to the power minus 2, right? This is for Newton into R square means what? L square is visual. No. Okay, I will write on top. Students will write on top once again. Don't worry. Please you copy it in here. You copy it in here, please. Okay, hope you have done this copy. Fine. I'm giving you 1 minute to copy. All right. So this will become now epsilon is equal to just dictate me. Here it was Newton, right? Newton means what? ml e to the power minus 2. Fine. Into on top I have Q1 into Q2. Nothing but charge square, right? So for one Q1 I can write A. A is what? Unit of current ampere. T into again second Q2. A into T divided by, okay, R square is what? L to the power 2, right? This will go, see here, L into L square, L to the power 3. M will go on top, it will become minus 1. Then L to the power minus 3. Now both see minus 2, here we have t to the power 1 and t to the power 1. So 1 plus 1 2, and this minus 2 will go on top, it will become plus 2. So we will be getting t to the power 4 into ampere square. Please cross check it once. Check, is it correct? AT means ampere, see, charge. Charge means what? Charge means charge is equal to what? Current into time, no? Charge means current into time. Fine. What is current formula? Then the natural formula of current is ampere. Few books it will written capital I also, so don't get confused, please. So A, fine, A into T. The natural formula of time is capital T. That's all. A into T. Got it? Any doubt? Yeah, because see, this was t to the power minus 2. Once it goes up, it will become plus 2. Fine. And this t and t square. So t to the power 2 from here and t to the power 2 from here. It will become plus 4. Because this is denominator, right? Numerator is in denominator. Got it?
Yes, sir.
Yeah. Instrument. Okay, fine. Why need acceleration here? Acceleration, how will you get acceleration? A for ampere, yeah, A for ampere. Can we have dimensional formula for a stress? Please get me the formula of stress. That's pretty easy. Anyway, get me the value or write in the comment box, please. Got it?
ml to the power of minus 3 t to the power of minus 2.
It's a Newton per meter square, right? Newton by force by area, right? So this will become ml t to the power minus 2 divided by what? L to the power 2. Fine. So we will be getting here ml minus 1, 1 minus 2 minus 1, t to the power minus 2. That's all. Fine. Hope all of you got this. Fine. Okay. Now, tell me the dimensional formula of a strain. A strain. Dimensional formula of a strain. A strain, you know, right? A strain means what? A strain means what? Change in length. Change in length divided by Original length. Original length. That's all. Fine. Yes, it's a dimensionless, right? So length by length will get cancelled out. So what you will get? No dimension, no unit, dimensionless. 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 Correct. Very, very good. Dimensionless. Next. Can you have angular acceleration? Angular acceleration. Angular acceleration. Notation is alpha. No, Rahul. The angular acceleration. Tell me, angular acceleration. Angular acceleration means what? Tell me. Angular acceleration means the angular acceleration means what? Tangential acceleration by what? Radius, right? Formula of angular acceleration is what? Tangential acceleration divided by what? Radius. Fine. Okay. So what is tangential acceleration means what? Acceleration only, right? This will give you meter per second square divided by meter. So meter per second square means what? L e to the power minus 2 and divided by L. So we will be getting t to the power minus 2. That's all. Got it? So angular acceleration is what? T to the power minus 2. Students, are you getting all the dimensional formula? All right, fine. Fine. See here, angular acceleration is what? Formula of angular acceleration is what? Tangential acceleration divided by radius. Okay, radius means what? Circle, radius of the circle on which particle is moving, right? So radius means what? Length only. So L. Acceleration means what? Meter per second square. So I wrote L e to the power minus 2 and divided by I have what? L. L and L cancelled out. So we got e to the power minus 2. Fine. Got it? Yes. Fine. Got it? Now I will write some a standard unit of length or practical unit of length. So we have done enough what? Done enough writing in what dimensional formula, right? Fine. Now next topic is practical unit of, that's a part of unit dimension only. Practical unit of length. Practical unit of length. Fine. First, astronomical unit. Astronomical unit. Okay. This is nothing but average distance between Sun and Earth. Fine. Astronomical unit. Fine. So one notation AU. AU. 1 AU is equal to 1.49 into 10 to the power 11 meter. One astronomical unit is equal to, this is U, okay, this is U. One astronomical unit is equal to 1.49 into 10 to the power 11 meter. Fine. Please note it down. Shortcut of what? Naveen Kumar. Shortcut of what? See, just formula. As far as formula part is concerned, okay, each and every topic I will explain in detail, so no need to worry about how to mug up the formula. Okay, so don't worry. Fine, got it. So, but in terms of length, few things you need to mug up. Per second. Second, this is first unit. Second unit is what? Per second. Per second. 1 per second is equal to 3.08. I think 3.08 568. 08568 into 10 to the power 16 meter. This is 1 per second. Per second, actually we are using, see here, if we are like, you know, how to measure the distance of sun. Okay, like see, if we see the sun, what is the angle it's making at our eyes. Okay, got it. In that okay, in terms of that we are measuring the per second, right? So I can define it like this. One is like this. See, suppose that our eyes is somewhere, see, we are here somewhere and sun is somewhere here, right? So how much this angle it will make sun? Okay, this first angle alpha, right? So distance at which this alpha is equal to 1 radian is called 1 per second. Fine, got it? That's all. Okay, and this alpha is called parallax angle. What? Parallax angle. Alpha is called what? Parallax angle. Alpha is called parallax angle. Like we are seeing a star. So how much a star is making angle at our eyes? This angle is called parallax angle. Fine. Okay. You know this distance. Apply formula tan alpha. Find this okay, this value. Fine. So distance at which this angle is 1 radian. Parallax angle is 1 radian. It's called what? 1 per second. This distance is called 1 per second. Got it? Next. So 1 per second is equal to 3.08568 into 10 to the power 16 meter. Please note it down. next unit of length is what? 1 light year. This is any doubt? 1 light year. What is 1 light year? Distance traveled by light in 1 year. It's called 1 light year. Distance traveled by light in 1 year. It's called 1 light. Okay, 1 light year. 1 light year. Okay, distance traveled by light in 1 year is called what? 1 light year. See how I'm finding. See here. How to find 1 light year. 1 light year is equal to, see here, 1 year means how many days? 365 days. 365 days you find into, in 1 day how many hours? 24 hours. In 1 day how many hours? 24 hours. Okay, fine. In 1 hour how many seconds? 1 hour is equal to 3600 seconds. So multiply by 3600. Fine. So this is time in terms of second, and the speed of light is what? Meter per second. Fine. So into the speed of light, 3 into 10 to the power 8. Got it? 1 second I repeat how I got. See, distance is equal to what? Time into a speed, right? I got time in what? In terms of second. So how I did? 1 year means 365 days. Fine. Okay. Now in one day, how many hours? 24 hours. 1 hour, how many seconds? 3600 seconds. Fine. Into the speed. The speed of light is what? Meter 3 into 10 to the power 8. What? Meter per second. Just multiply. So if you do all the calculation, you will be getting, just I am writing 9.4607 3 into 10 to the power what? 15 meter. And see, here I am taking average year. Average year is in average year means, see, here it can be for 365 days also and 360 leap year. 366 days also, right? So this will become 360.25 because every 4 years I am getting one leap year, right? Got it? So I have added 365.25. Correctly, I say 365.25. Why 0.25? See here, 1 day will increase in every 4 years, right? So 1 by 4, 0.25. Got it? Yes? Yeah, total second in this is total second in 1 hour, and whole thing is total second in 1 year. 1 year. Fine. This is total number of second in 1 year into the speed. That's all. Okay. Next. These are like this is like we are measuring like macroscopic level. Let's come to microscopic level. Fine, these are all the distance at the macroscopic level, like distance between sun and moon and earth, all these things, right? Next, let's come to distance at the microscopic level. Okay, done with copy? Yes. Next. Other unit of length is angstrom. 1 angstrom. 1 angstrom is what? 10 to the power minus 10 meter. Similarly, 1 micrometer. What? Micro. 1 micrometer. Micro means 10 to the power minus 6. This will become 10 to the power minus 6 meter. Similarly, I have 1 nanometer. 1 nanometer means 10 to the power minus 9. 10 to the power minus 9. Then other unit is what? Fermi. 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 One Fermi shall be 10 to the power minus 15 meter. Fermi we are measuring, okay, distance between nucleus in terms of Fermi. Okay, distance between the what? Nucleus. I mean nuclei of an atom. So distance between nuclei of atoms we are measuring in terms of Fermi. One Fermi is equal to 10 to the power minus 15 meter. Got it? Yes? Fine. Okay? So this is all about unit and dimension. One question can be expected from this dimensional formula in NDA. A scoring, okay, in physics in NDA is not a big thing. Once again, I am saying you. Just stick to the basics, concepts, and formulae. That's all. And rest of the things leave it to me. I will take care of it. Only thing is that be thorough with your basic concepts. That's all. Paper will be very easy, provided you are thorough with NCERT 11th and 12th syllabus. Even next chapter to this is what? Kinematics, right? You know, kinematics, like, you know, so many times I have seen back to back they are giving two questions from graph. Graph of velocity time, then displacement time. From there, they are giving two questions back to back. How easy it is. So you can't expect which, like, you know, which topic they are going to cover. Last year only, I think, yeah, from here, electromagnetic waves, they had given 3 questions in physics. Electromagnetic waves. That's, I think, hardly it will take 1 hour in teaching electromagnetic waves, right? From there, they had given 3 questions. Next. Fine. Now, let me introduce the next topic, kinematics. What? Kinematics. Kinematics, right? So here, kinematics is what? It does not include any mass. It does not include any mass. We talk about acceleration, velocity, fine, and displacement, fine. So kinematic means what? Motion, right? What? It's motion. Now see, motion, it can be of how many types? 3 types. Linear motion, alignment motion on a straight line, First what? Motion on a straight line, right? A straight line. Like motion of a car on the road. This is what? Okay, this is no. What time will you stop? 1 o'clock. When they will come back? 2 o'clock, right? Okay, and this is called one-dimensional motion also, right? What? One-dimensional motion. Also, one-dimensional motion, fine. Also, motion on a straight line is also called one-dimensional motion, right? Second, 6 to 5 minutes. Second, two-dimensional motion. Two-dimensional motion, right? Like here, you need to have a two component of velocity. One like maybe along x side, other maybe along y axis side. One is along x axis, other maybe along z axis, right? So here motion will be along two sides. Fine. That's why it's called two-dimensional motion. Here particularly we'll have two kinds of velocity. Okay, along one along x axis, other will be along y axis or z axis. Fine. Got it? Example: projectile motion. Projectile motion, right? Fine. Two-dimensional motion, because here I need to have two component of velocity. If you are throwing some ball at some angle, that will be the case of projectile motion. Okay, we'll talk in detail about each and every motion, don't worry. Okay, which formula will be applicable? Okay, where we'll talk about everything. Next is three-dimensional motion. What? Three-dimensional motion. Fine. Three-dimensional motion, right? Got it? But students, one more thing. Before getting into all these things, okay, actually I should have started vector. How many of you have proper idea of vector? Because if you don't know vector, here onward, rest of the topics are going to be difficult. So vector is a vector is a prerequisite for all these things. Without vector, you can't learn. Okay, all these chapters. I mean, after kinematics, everywhere we are using vector. Newton's law of motion also we are using vector. Work power energy also we are using vector. Okay, fine. So what I will do in next class, I will give you some brief idea of vector. Okay, that means how to take component, how to find the resultant of two vectors. Okay, at what angle, what will be the angle between the two vectors. Okay, triangular law of vector addition, and the ground law of vector addition. I will give you some brief idea about vector, so that you could be thorough with this and you could not find any difficulty in the rest of the topics. Fine. So before getting into all these things, in next class I will give you what idea of vector. Got it? Then only I can go ahead. Otherwise it will be difficult. Fine. Yes. Say yes. Fine. Got it? Yes, students, any doubt? Okay. Now see, three-dimensional motion, right? Suppose that any word is flying, right? So it may not be flying in a straight line. So it will be flying here and here along zigzag path. Okay, in here. So here it will be dealing with three component of velocity: x component, y component, as well as z component, right? So here three component of velocity will come into picture. Then we call it as a three-dimensional motion, right? Got it? Fine. Okay. So guys, so anyway, so we have done fine. Now it's clear. My video is clear. Yes. Fine. So guys, students, next class, okay, we'll talk about vector first, then I will get into all the things, right? So okay, see you guys in next class. Okay, okay. Again, we will have lunch break from 1 to 2. Again, 2 o'clock we will have other class.